Sunlight. I have light. It's only 1700. That's 5 o'clock. So 2 more hours. It'll still be daylight. It'll still be bright and nice outside. I typically, when I do user group meetings at 1700, and you know, it starts at 5 or 6. I can take for granted the light in the very beginning, but then by the end of the thing, it's dark in here, and I'm just a shadow, and it looks weird. So I have to run over to the lamp and turn it on to make sure I don't get shrouded in darkness midway through the talk. So I'm just so happy that we get to do this together. We get to have this conversation. And of course, we're nearly upon my absolute all-time Double Dutch favorite season of the year, spring. Spring is nearly here, which makes me very, very happy. You know, I hope you're all having a great day as well. I don't know where you are in the world. Hopefully you're here in San Francisco, in which case you can appreciate the wonderful, wonderful light that we have beyond us. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate. I have been for the last 10 plus years, since August 2010. I'm a Kotlin Google developer expert, a Java champion, and most importantly, first and foremost, above all things, I am at your service. I'm here to do whatever I can to help you get on the road to production. So if you should have questions, when ineluctably have questions, don't hesitate to reach out to me via Twitter. My direct messages are wide open, or you can just flag me in the, in a public tweet as well. And my email is right there, josh@joshlong.com. So should you have questions, comments, feedback, whatever, I'm very happy to hear and engage and do whatever I can to help. And of course, we're going to go through a lot of code, a lot of stuff today, but that code is there. It's on that GitHub repository. You can see that the name, it implies a date, but there's no date. It's timeless. It'll just keep changing, and I'll update it accordingly. Okay, so with that, I worked, as part of what I do, I used to travel. That was a thing we could do before the pandemic. I don't do that all that much these days, obviously. But before, I had the privilege of spending time with people all around the planet, talking to people about spring. And every year I did about 650,000 miles on planes, talking to different organizations, different human beings. And one thing that is common, one thing that's consistent, is that they love getting to production. They love building software that's intended for production. So this is why I love talking about cloud native Java. It's Java through the prism of, I want to get to production. And as part of that, of course, I've done training videos. I've done books. I wrote a book called Cloud Native Java about 4 years ago now. I have a podcast called A Beautiful Podcast, which is just me every Thursday night here in San Francisco, but Friday for most of the rest of the world, talking to people who are smarter than I am. Again, obviously a low bar, about all things production, about all things cloud native, and about all things spring. I have a blog I do every Tuesday. That's yesterday, for those of you keeping track. It's just a recap, with apologies to the Times, of all the news that's fit to reprint. I have a screencast series I do every Wednesday, or usually on Wednesdays, which is just me looking at some corner of the ecosystem, exploring some aspect of the ecosystem in depth. And I've got a really interesting one that you might like, that was just released on Spring Cloud Gateway. It's an hour and 40 minutes. It's a very long thing. It features interviews from people who helped contribute to the Spring Cloud Gateway ecosystem. It even has a brief discussion of the brand new, just announced Spring Cloud Gateway for Kubernetes, which we'll talk about ever so briefly later on. It's a product, a very useful, very cool product. And of course, I have a book called Reactive Spring, and Reactive Spring is all about how to build applications that take advantage of reactive programming. So now I'm going to leave that slide there. I'm backing away, and we're just going to talk, okay, just for a few minutes. We're going to talk about what motivates cloud native Java, what motivates building cloud native applications. For as much as I love Spring, and I love the technology, you can see the Spring t-shirt and so on, as much as I love all that stuff, that's not why we're here. It's not the thing that motivates me. It's not the reason that I jump and spring out of bed every morning. What I care about is helping people build software intended for production, helping them get to production. And a lot of organizations want that same thing. They want to go faster. They know that they need to go faster. They understand the existential threat implied by organizations that can go faster, and they want to know how to go faster themselves. And they're not just trying to go fast for the sake of going fast. They're trying to go fast for the sake of learning, for the sake of building upon what they've learned, from responding, for responding to what they've learned, and to iterating, right? They want to go fast to be able to improve themselves. They want to build learning organizations. And so speed is a way to do that. It's a way to make more mistakes and get those out of the way and respond to those mistakes. The idea being that basically, you're going to make the same mistakes no matter what speed you go. We might as well just get it done quickly, right? The faster you can pivot, change direction, respond, etc., to the marketplace, the better situated you are, right? And so everything that we've done in the last 20 plus odd years, if you think about it, really is not technically all that novel. I mean, there are some, don't get me wrong, there are some things that are just, new things or revolutions. They're straight out of nothing. They're just brand new, right? But mostly what we're talking about these days, when we talk about software today in 2021, what we're talking about are faster versions of things that we already had before, right? We want we want continuous delivery because it allows us to deliver software into production in a repeatable, fast fashion, right? We want continuous integration. We want cloud computing. We want microservices. We want test-driven development. We want all these things that allow us to deliver software faster. And microservices in particular are something that I care about because, I mean, I care about all of it, but I care about microservices because they allow us to think about software and how we build our systems. And they allow us to build software that optimizes for organizational velocity, right? This is very important here. Organizational velocity is what we care about here. So when we talk about microservices, we're not talking about small code bases. It's actually a really big misnomer, right? When we talk about microservices, what we're talking about are small teams, small groups of people working on small code bases. The smaller the code base, the fewer the people that work on it, the easier the task of integration and synchronization and stabilization, and then eventually deployment into production. The easier it is to then iterate and move forward, right? Imagine you have a large organization with a large code base, a lot of people working on the code base, a lot of people that have to be involved in every little decision, every little code change, every little code freeze. This becomes problematic, and it means that what should be a routine sort of every hour, every minute, every couple of minutes kind of thing takes days or hours to get done, and people are frozen in the meantime, waiting for them to be able to make changes. And if there's any kind of bug, then you have to stop the whole line, right? You have to stop the line in keeping with lean manufacturing and so on, right? This idea of catch defects quickly and respond quickly. If that's the case, then you have a large code base, then you have to stop everybody. So it's just generally not a great idea to have a large code base because you have a lot of people involved and it's wasteful. Instead, you'd break apart the large code base into smaller chunks, small batches of work. And the smaller the batch, the smaller the group of people that work on it, the better. And so this is very important, right? We want small, singly focused batches of work, small, discrete, singly focused, independently deployable batches of work. That last bit's very important, independently deployable. That refers to this idea that software should be deployable independent of other pieces of software, other modules. This is, of course, not a controversial idea, right? We want modularity, we want independence. This is very, very important, right? We want that independent deployability because it means that we're not waiting for other parts of the organization to synchronize, to integrate, right? If we can deploy independently, we don't have to wait for somebody else to pull our change in, link it into the giant monolith, and then deploy that. We can deploy without being beholden to the rest of the ecosystem, to the rest of the organization. That means that we can move forward, get feedback from the outside world, see what we're doing, make changes, etc., without waiting. And that's where we get a lot of power, is that independent deployability. But of course, when you deploy independently, when you move independently, you've got a, obvious, when you think about it, implication, which is that now your software, which would have been linked together in a monolith before, now has to communicate with other modules in the system over the network, right? It's now a network-based service, and therein lies the rub. That's the complexity that so much of us fear, that so bedevils so many of our deployments, is communicating state, coordination, that kind of stuff. That's a problem, right? That complexity is not trivial. It's not free. We have to address it. The thing to keep in mind, however, is that we do it because it gets us something more valuable. Yes, there are more moving parts. Yes, that work is more significant than just doing a monolith or a small monolith. But the benefit is that as an organization, it allows us to go fast. It allows us to go faster. So the question is, can we get the best of both worlds? Can we have our cake and eat it too? Can we have software that's deployed as microservices while paying down some of the implied complexity of building distributed systems? And that's what we're going to talk about today, my friends. It's just a bunch of things that we can do to pay down some of that technical debt, some of that complexity. And of course, to do that, we're going to use Spring, obviously. And we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not already been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a brand new application here called Customers. And we have before us a few choices, or at least the appearance of choices. We have the choice of packaging. Which kind of packaging do we want to use for our binary, be it a .jar or .war? Obviously, I'm all about discrete, independent and deployable things with fewer moving parts. And so that implies .jar. I don't want to have to deploy this into some other application server. There's no need for those extra moving parts today. I can just bundle the web server in my application binary. And this is, of course, in keeping with my own personal and guiding personal philosophy of make jar, not war. And again, lots of things that you could do, but I encourage you to select and embrace the defaults. Then we have the choice of what version of Java we would like to use. Yesterday, we released Java 16. We saw Java 16 get released. So you can expect that in no time at all, Java 15 will be supplanted by Java 16 here on this Spring Initializer. But for the moment, Java 16 is the current supported version of Java, and Java 11 is the current long-term supported version of Java. Java 8 is a non-choice. A non-choice is not just a deliberation that you can make for different types of Indian breads. It's a choice that you should not make. It's a choice that you should not make under any circumstance. Java 8 is creakingly old, expired, legacy, past its prime, stinky, not fresh, not good. Don't do it. Be the change you want to see in the world. Do the right thing and move on to the newest, latest, and greatest versions of Java. Java 11 and 15 and 16 have a lot of really nice features that make it faster, more robust, more container ready, more production ready, more observable, more memory efficient. It has lots of nice syntax that makes it more fun as developers to get work done. Java 16 has multi-line strings and records like data classes or case classes. That's built into Java now. It's not even a preview feature. You can do all that. There's even smart Kotlin-like pattern matching, instance of pattern matching. So there's some really interesting things in Java today. Java 11 is also chock full of good stuff as well. Either way, you're in good hands if you should use one of those versions of Java. They are technically superior to Java 8 in every way. They're also morally superior to Java 8 in every way. Trust me, my friends, you don't want to have that conversation with your children when they find out that you're using Java 8 in production. Don't do it. Do the right thing. So we're going to leave those as they are. And then we have the choice of what technologies we want to add to our application. I'm going to use Lombok, which is a compile time annotation processor. I'm going to use the reactive web support. I'm going to use R2DBC, which is the reactive relational database connectivity abstraction. I'm going to use H2, which is an in-memory embedded SQL database. And then I'm going to use the Spring Boot actuator. And then I'm going to use, we'll come back to that later. We'll do that later. So I'm going to use these dependencies. I'm satisfied with them. I'll hit generate, and that's going to give me a zip file, which I'll open up in my IDE. So let me, goodbye, generate, good. Goody. Okay, there's our application, public static void main. Here's our basic Spring Boot application. And what we're going to do is we're going to write data to the database. And so in order to do that, I'm going to start with the domain model as always. So I'm going to create a class called a customer. And that customer will be talking to a SQL database. And that SQL database will have a primary key, which I'll signal by using the ID annotation. And this is an entity. It's a thing that's going to have state and getters and setters and toString and equals and hash code. And so I could, of course, do all that kind of stuff myself. I could do, getters and setters and all that kind of stuff. I could do toString and all that. I could do all that kind of nonsense. But rather than, worsen my code with all that tedium, I'm going to use Lombok. Lombok's a compile time annotation processor that makes trivial the work of actually synthesizing at compile time those getters, setters, toString, equals, hash code, etc. I also want to create a repository that handles the tedious, soul-annihilatingly boring read, write, update, and delete life cycle of our data. Now, this repository is an interface, but Spring is going to provide an implementation of that interface that provides all the things that we want. So save, delete, count, find by ID, check if it exists, all that kind of stuff is implied by this interface. And you can see that there are a number of different methods here that accept different parameters, the first and foremost of which is a publisher. So when we talk about cloud native Java today, for me, that assumes reactive programming. Reactive programming is a way to write software that gives us three very key characteristics. One is better resource efficiency. That is to say, when I build a service that's reactive, I make sure to repurpose or reuse all the threads in my application. The last thing that I want is to have an application that's just sitting there idle, waiting for I/O to happen, doing nothing but sitting on a thread and squatting on it and preventing everything else from the system from using it. So instead, I use asynchronous I/O. I use APIs that allow me to ask for data and then move on. I can do whatever I want while the data is arriving. And then as soon as it arrives, I get a callback, an interrupt that allows me to then proceed with the data in hand. But in that interval between when I've asked and when the data has arrived, everything else in the system can reuse that thread. That's very important. So resource efficiency gives me better scalability, right? The other thing that reactive programming gives me is ease of composition. With reactive APIs, you only have one API, one abstraction. So no matter what the shape and timeline of your data, you have one type that you can use to compose and iterate and work with that data. And so to understand what I mean, consider what it's like to have data coming from a RabbitMQ queue, or an HTTP REST service, or a SQL database, or Kafka, or service and event, or WebSockets, or whatever, right? Data in those different scenarios might arrive asynchronously. It might arrive in an unbounded fashion, right? You might have infinite records. You might have just 2 records. You don't know. You might have records that will arrive immediately as soon as you ask for it, or that might arrive in a trickle over the next year, right? In a slow sort of drip of records. Whatever that is, you want an easy way to consume that data. And so publisher, this reactive streams type, gives you that. You have one kind of stuff, one thing. The other thing that we want when we use reactive APIs is to get more robustness, to resilience, right? If you want to build systems and services at scale, you need to embrace the reality that things are going to fail. At sufficient scale, things fail. That's a fact. It's ineluctable. It's just a thing you can take for granted when you wake up in the morning, along with death and taxes. At sufficient scale, all systems break. You can ask anybody from a large enough website and they'll tell you. For example, at Google, there has not been one second in the last few decades where something wasn't broken somewhere. And that's okay, right? People don't lose their minds about it. Things break, they build their software so that even if a computer, burns up or whatever, it's fine. The rest of the computers just keep going. They build systems that are designed to degrade gracefully. And by the way, that is why when a website like Google does, on the rarest of occasions, fail, it's news, right? It's on CNN. The whole world knows about it, right? It's a really big deal because they never fail. So 3 things: resource efficiency, ease of composition, and robustness, right? Reactive APIs give us all that. And these are 3 key ingredients when we talk about building software intended for production. So I have this publisher. This publisher comes from the reactive stream specification. This specification is just a jar with 4 foundational interfaces. These interfaces provide just the absolute bare bones basics for us to describe potentially unbounded, potentially asynchronous, potentially latent streams of data. A publisher is that thing that we use to describe that kind of data. A subscriber subscribes to the updates or to the new records that are coming from the publisher, that are being published by the publisher. When the subscriber first subscribes to the publisher, it is given a subscription. And the subscription is what the subscriber uses to request more data of the publisher. It's also what the subscriber uses to cancel the stream of data from the publisher. So the subscriber can say, hey, I want 10 records, I want 1,000 records, etc. And they can stipulate as much here. If they don't want any more data, if they're tired of it, and it's just been nothing but trouble, they can cancel the stream of data here as well. If they send in integer.max value, then they'll just get all the records that are available as fast as they're available. This is very interesting though, because now the subscriber can control the rate at which it consumes the data from the publisher. The publisher cannot, in other words, overwhelm the subscriber. You can't denial of service a subscriber that is itself driving the rate at which that data is being delivered to it, right? That's critical, and it's not controversial, right? I know I'm talking to you about it right now, but consider that when we build network protocols, low-level network protocols at the TCP, UDP level, one of the hardest things to get right in that world, and one of the reasons why there's been so much work done in the last 60, 70 years, ever since one computer had to get on the same network as the other and talk to it. One of the things that we've worked so very hard to do is to make it easier for people to build that state machine that handles the scenario of one side moving faster than the other, right? That state machine is trivial in concept, right? We just need to have something that makes sure we don't get overwhelmed, but it's really hard to get right in practice. And this is why we talk about flow control, right? Flow control in a network protocol is everything. In fact, that's the genesis of the NETTY project, N-E-T-T-Y. That's why it was created, right? It was created by Trustin Lee to address that state machine when writing network protocols. It's very, 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 very important to get right. But we don't disagree that should happen, right? Ditto for at the macro level, the systems level, the architecture level. We build services and we decouple them, we decompose them, and they communicate often in terms of message queues. And a message queue has the effect of buffering excess demand. That way the consumer, the thing that's processing the data that's coming off that message queue, can drain the message queue as fast as it can and no faster, right? You can't overwhelm a consumer that's on the other end of a message queue, because a message queue serves to act as a stopgap, as a buffer to absorb the extra demand. So these are very important concepts, and then now all we've done is we've surfaced them as part of the API. I mentioned that the Reactive Streams API has 4 types, but I've only shown you 3. I showed you publisher, subscriber, and subscription, right? The subscription gives you flow control. When the records are delivered, they are delivered in the on-next method. When there are errors, those are communicated in the throwable, accepting on-error method. And when you're done processing the data, that's signaled here in the on-complete method. The 4th type is called a processor. A processor is just that. It's a bridge, a source and a sink, a producer and a consumer, a publisher and a subscriber. And that's it. That's the entire Reactive Stream specification. Those are fairly foundational. I think you can agree. Those types are part of the JDK itself as well. Job util concurrent flow dot processor dot subscription dot subscriber dot publisher. They're in the JDK itself now. And so these types are, except for the package, of course, and the namespace, they're identical, method for method, signature for signature. And they're so identical, in fact, that there's a very trivial flow adapters class that's included in the Reactive Streams jar. If you're using Java 9 or later, you can use the JDK version. If you're using Java 8 or later, which of course you're not, right? You're using the latest and greatest version, of course. We had this conversation, just nod. You can use the Reactive Streams types. These are interchangeable, and there's these methods that you can use to adapt one type to the other. So here, given a Java util flow, I can get a Reactive Streams publisher, right? Given a Reactive Streams publisher, I can get a Java util flow publisher, okay? So these are foundational, but again, they don't really, they describe the basics of what we're trying to do, but they don't give us an easy framework with which to do it, to address data flow problems, right? And so for that, we have another framework called Reactor. Now, Reactor is a project that the Spring team built to address reactive programming concerns. It provides 2 specializations on top of Publisher, or of Publisher, the first of which is a flux. A flux is a reactive stream that produces 0 to n values, where n is potentially unlimited, right? A flux has lots of operators. Look at those operators, so many operators. These operators help us think about and work with the data that we're processing. So you can do things like mapping and flat mapping and filtering and all that kind of stuff. And you can see there's a lot of code here. This is not the kind of code you want to write. So don't, just let the framework do it for you. There's also mono. Now, mono is a reactive stream that produces at most 1 value, so 0 or 1. A mono is a reactive stream. A flux is a reactive stream. They're both publishers. They just have different semantics. Think of mono like a completable future, but with back pressure. A flux is like a Java 8 stream, but with back pressure. So now we have these basic types. We have a repository. Let's initialize some data in the database. So what I'm going to do is I'm going to create a bean application listener, application ready event, good, and we're going to do customer repository, good. So I'm going to write some data to the database. I'm going to use some names here, some people on the Spring team and the team Tanzu. I work on the Spring team. The Spring team is part of Tanzu. Tanzu is part of VMware. So we're all one big happy cloud native family. So my name is Josh. So lovely to meet you. I'm joined, of course, by my friends Anand and Kirsten. And of course, there's other people on the Spring team as well. Let's see. Good. Phil, Spencer, Yushin, Elia. Okay, lots of people, right? Lots of nice people on the Spring team. And those names, I want to visit each name like so. As a new customer, passing in null for the ID and turning it into a reactive stream of customers. And then for each one of those, I want to take the data and then write it to the database. So I'll say customers.map. And I want to use the repository. I'll say customer repository.save C. And that'll give me a reactive stream of customer. Well, of course, I don't want two reactive types. I want to flatten, kind of like the COVID curve. I want to flatten our reactive streams, right? So I'm going to unpack that intermediate type there by using flat map, right? So flat map unpacks that intermediate type, and what I'm left with is a stream of just customer data. Now that's a view, if you will, on the data, right? So what I've done is I've defined 3 steps: names, customers, and the saved, persistent customers. Now, if I were to run this code as is right now, nothing would happen. You see, I haven't actually activated anything in this pipeline. Think of these pipelines as just that, pipes through which water, or in this case, data, will flow. But if you don't turn on the faucet, no water flows through the pipes. You need to activate the pipeline. You can say saved.subscribe, and then that'll actually kick off the pipeline. It'll turn on the water. That said, keep in mind that subscribe is asynchronous. So if I were to do this, now we're done. There's no guarantee that this will execute before this is finished. And so you might actually see this print out first, and then this stuff get written to the database, chronologically in terms of wall clock time, right? It's a little confusing. So you need to use operators to ensure that one thing precedes or succeeds the other. And we can use the operators that are provided out of the box. But before we do that, I'm going to clean up the code here a little bit and reduce the steps down to just this one little variable here. So what I'm going to do is I'm going to say, I've got my names. I want to get all the data back, right? All the data from the database. So I'll say customer repository.find all. All right. And then before I do that, I'm going to get the names. I'm going to read the data, and then I'm going to print out something. But I also want to initialize my database table. Remember, this is an in-memory database, so I need to actually initialize my database when the application starts up. So I'm going to use the reactive database client. So I'll say dbc.sql create table customers, ID serial primary key, name var car 255 not null. Okay, and I'm going to say fetch. I'm going to say rows updated. And voila, there's my data. So I've got DDL, I've got the names, I've got all the data. I'm going to say DDL.then many names then many all, and then I'm going to print out the results that come back from that. So I'll say system out print line. So that's the actual pipeline. I'm composing these 3 different steps into one overall flow, one large flow. Very, very concise. Okay, let's go ahead and run this and see what we get. Compilation for the win. Okay, what happened there, huh? What did I do? Stack traces from miles. Create table. Oh, I gave it the wrong DDL. Create table customer. Goody. So there's our data. It worked. There we are, all 9 of us. Let me get rid of somebody. So it's nice, round 8. There we are. Okay, so now we have 8 records in the database. It worked, of course it worked. That was a demo, it was always going to work. The very natural next step is to create a HTTP endpoint that I can use to get access to the data. So I'm going to create a REST controller. I'm going to inject the customer repository, and I'm going to inject it into the constructor, which I'm going to synthesize with this Lombok annotation. And I'm going to return the data for this repository like so. And we'll go ahead and restart. Okay. Stop and rerun. Thank you. Goody. So there we go. Let's go to the browser, localhost, customers, and voila. There's our data. It worked. We have our records. Everything's fine. Are we ready for production? I should say not. I think we have some work to do. Obviously, what I want to do is I want to support observability. I want people to be able to ask questions about the service to see if it's healthy or not, etc. I want to have easy options to integrate with the platform. All this requires that I do more than just build a REST API. An HTTP REST API does not a microservice make. So to support observability, I've added the Spring Boot actuator to the build. Okay, the Spring Boot actuator stands up endpoints that give us information about our service. And I can actually go to the /actuator, and I can get a kind of menu of the different endpoints that are available. But you see, to keep things secure by default, we don't expose all the different endpoints. And even those that we do, we limit the output. So you get the just sort of abbreviated response. So in order to see everything that's happening, you have to go to application.properties, exposure, all, health, always, and probes equals true. Okay, so I'm going to restart having done that. Good. So here we go. If I go back to the health endpoint, you can see there's a lot of data here, right? It shows me the file system as, this is my file system and the status. You can see my connection factory, my SQL database abstraction, my asynchronous IO reactive database connection called R2DBC has a validation query for the connection pool. It says everything's fine. So all that is saying, look, I've got these different subsystems. Should they fail, then the aggregate status will reflect that it's down. I've also, you saw back in this configuration, I enabled probes. Now these are for Kubernetes. These health endpoints provide two different probes, liveness and readiness. In Kubernetes, a liveness probe determines whether the service is still healthy. That's basically the Kubernetes equivalent of just the health endpoint. Hold on 1 second, friends. Thank you. The readiness probe tells us whether the service is ready to start serving traffic, right? So these two different probes are critical for us to be able to integrate with the platform to give it an idea about whether the service is ready or not to help us with stuff. So to see that, I can go to the health endpoint, or not. No, sorry, health liveness, right? Ditto for the readiness probe, so readiness, okay? So these different endpoints give us information about the health of the service. Now, in order to see that that this is something you can exert control over, I'm going to create another REST controller called the availability REST controller. And we're going to create an endpoint called down. And when you invoke that endpoint, it's going to publish an event in the application context, and the application context will then communicate with that endpoint. And we can then force it to register that the service is down for whatever reason. So let's say something goes wrong and you want to signal that the service is no longer available. Well, you can do that here by saying, liveness state.broken, right? So I'm publishing an event in the application context that'll asynchronously be communicated to the endpoint in the actuator. And when that endpoint goes down, when it signals that event, it'll set the aggregate status to down. So this still says up at the moment. Now let's go here, curl -x post HTTP localhost host 8080/down, and then did I do that wrong? Curl -x post. This is the readiness probe. I was doing liveness, so that's down. Okay, so you can exert control over what happens and how whether the service gets shut down or not. There's a bunch of other endpoints that are in the actuator as well. Besides the health endpoint, there's your caches, which shows you which cache managers have been configured. You've got the environment, which shows your environment variables. You've got the loggers, which shows you all the different loggers and the different log levels. You can post to this endpoint as well, by the way, to set a log level at a different type if you want to, for certain things that are refreshable. You've got the thread dump, which shows you, it'll give you a thread dump of all the things that are happening in the application, see which threads are waiting and whatever. You've got mappings, which shows you all the different HTTP endpoints that have been exposed from your service from an HTTP perspective, as well as the handlers that are actually producing those responses. So if I go to /customers, you can see that the customer's REST controller .get responds to /customers for an HTTP GET, and it returns a reactive stream type. And you can see the configuration about which content types it produces, which content type it accepts, etc., and so on. So all this stuff is there, so you can kind of understand at a glance what the service is doing. We've got the beans endpoint, which shows you all the objects and how they're wired together. You could dump this into a graph database or something like that and get a very nice visualization of the topology of your objects. You've got all sorts of good stuff there. Metrics. Metrics gives you just that. It gives you metrics. It gives you, this is great for low cardinality data like, CPU or memory usage or HTTP server requests or whatever. This is different from low cardinality data like individual transactions, right? So if you want to see a statistic about all the HTTP requests, that's a metric. If you want to see the details of a particular request, that's a distributed trace. And you can support distributed tracing with something like Spring Cloud Sleuth. But for metrics, this endpoint gives you an idea of what keys are available. But that said, this is just the beginning of the journey. You see, this endpoint is powered by something called micrometer. Micrometer is an abstraction. Think of it like SLF4J, but for logging. It's a logging facade for metrics. And so it has integrations with a whole bevy of different metrics time series database backends, including but not limited to AppOptics, Azure Monitor, Netflix's Atlas, CloudWatch, Datadog, Dynatrace, Elasticsearch, Ganglia, Graphite, Humio, InfluxDB, JMX, KairosDB, New Relic, Prometheus, SignalFX, Google Cloud Stackdriver Trace, StatsD, and of course, VMware's own Wavefront, which I quite like. And by the by, you can, whoops, wrong one. You can go here and you can just choose Wavefront. And that's it, by the way. You add this to the class path and you generate the application, just run the application. It'll actually negotiate a brand new account for you and create a dashboard that's pre-configured with everything you need to be able to use it from a Spring Boot application's perspective. This is a great way to get started. It'll then dump out some properties that you can then feed into the application on subsequent runs. And that way you can keep, you'll be able to pin the one dashboard that you're using. And keep it for later, right? This is awesome. It's just so easy to use. And by the way, Reddit, reddit.com, they use Wavefront, right, at scale. So it's not just a good idea because I'm saying it. It's a good idea because it scales. And it also is one unified thing. It'll give you metrics and distributed tracing information all in one dashboard, one platform. So rather than using Zipkin and then using Prometheus, you can just use Wavefront, one database. You can easily pivot across the different data sets and so on. I did a blog with my buddy Tommy Ludwig, metrics and tracing. I think you might appreciate it. It's called Metrics and Tracing Better Together. And we wrote this way back in February 9th of 2021, so just a little bit more than a month ago. And it talks all about that ability, that opportunity of what happens when you can correlate or pivot from one data set to the other in the same application, in the same dashboard. We're using Wavefront, but the ideas are equally applicable to other things as well. So I love these endpoints because they give me the ability to see what's happening at a glance. Now, let's return to the discussion of that health endpoint. That health endpoint tells me whether the service is available, whether it's up or not. And you saw that I can use an event to shut down the service. I can say that the service is down, right? And if that goes down, then the probe will show that it's down. And then Kubernetes, which is it's gonna pull that endpoint, it's gonna probe that endpoint, it's going to see that the service is down, and then what? Well, it's gonna shut it down eventually. It's gonna shut down the service and then restore and replace it with another instance that it's gonna spin up. So the question is, what do we do when we get the shutdown order, right? What happens when we go down? Well, Kubernetes is gonna shut down the application and then immediately kill the container or not, right? We can actually tell it to do two things instead of one. We can tell it to send a SIG term signal to our application give us a buffer period, a time during which we wait for things to happen, and then send a sig kill. And that buffer, that interval between the sig term and the sig kill, is very useful because it gives us a chance to get our application's affairs in order, to shut down everything, to stop any in-flight transactions, to reject any new requests, but drain off any in-flight requests, right? This is an ample, wonderful opportunity for us to clean up our service so that we don't just get, things don't stop in a sort of cataclysmic, apocalyptic, end of thread days kind of thing, right? And so to determine whether we do that or not, we have to take advantage of graceful shutdown. So you can say shutdown equals immediate, that's what the default is, or you can do graceful. And then you can show phase, let's see, timeout. You can say I want the timeout to be 30 seconds. So it'll send, if you do graceful, it'll send a sig term, then in this case, if we've configured Kubernetes appropriately, it'll wait 30 seconds and then it'll send a sig kill. And during that 30 seconds, we can stop any in-flight transactions and so on. So this is very useful to see what's happening. If I were to create a slow HTTP endpoint that takes arbitrarily, 40 seconds or 20 seconds, you would see that this is gonna, if I hit Control C in the console while that thing is running, the console will say starting graceful shutdown, completing any in-flight requests, and then whenever that finishes, immediately after that it'll shut down it'll shut down the application. Very, very convenient. It makes it easier for us to get to production in a reliable way. Okay, so we've got an application. We've got our actuator endpoints. This endpoint, I've showed you all the endpoints that are interesting except for one. There's one more called info. Info is empty. You can put information about the application itself in this endpoint. This endpoint gives you details about about arbitrary details about the state of the service, about the information about the service, etc. Things that you can use to understand what the service is, which one it is, how it's doing, etc. You can identify it, that kind of things. And you can actually customize this endpoint in a number of different ways. One way to do that is to use properties. So I can say info.foo equals bar. Very, very convenient, right? So if I restart this, I'll see that will be a key foo and the value will be bar. I can put anything I want there, right? I can do anything I want there just to customize it that way. But the other thing I can do is also to customize it at build time using the git commit ID plugin. So if I go back to my Spring Boot starter parent and then go up to Spring Boot dependencies and I look for git commit ID, come on. Here we are, git commit ID plugin, Command C, and go back to my build down here and paste that in. And voila, there's my plugin. I'm just going to enable it. I'm basically just opting in to the plugin as it's already configured. And this plugin will capture information about the git commit that triggered the change that eventually resulted in the push to production, that then triggered the CI build that is the result of the changes, and that CI build will, in theory, be deployed to production. So it can be very useful to have this information. So I'm going to do git init, git add, git status, git add.mbn, git add.gitignore, git commit, YOLO. Okay, good. So now I've got that. I'm going to do maven clean package. Okay, let that run. It's going to start. There we go. So I've just rebuilt the application. Let's go ahead and restart it now. Okay, come on. Let me by the way, I'm going to put this here for reasons, and we'll see that later. So if I restart the application, what happens? Here we go, run. Okay, and now you can see git branch, commit ID, all that kind of stuff is powered by that plugin, which creates a file called git.properties. Well, in theory it does. Where did that file go? Synchronize, reload from disk, good. Target, git.properties. So there we go. There's this thing that was just created on my local machine. You can see the commit ID, the name, etc. So this is another way where we can change the default behavior of the application. And with all that done, I think we're just about ready to go to production. So the question then, of course, is how do I get this into production? For so many of us today, Kubernetes is production. And when I talk about taking my idyllic Spring Boot application and moving it to production, people with they recoil in horror at the prospect of having to write YAML, which of course we all know is the reason that people leave IT. Or having to write Docker files, which is the other reason people leave IT. So I don't want to inflict any of that on you. I want to help you get to production faster. And so we can use something called a build pack. Build packs are a great way to give an application artifact, to package an application artifact as a container and then deploy that to production. Now, of course, build packs are generic. They're the sort of work of a collaboration between Heroku and the Cloud Foundry team at then Pivotal, but now Tanzu and VMware. And build packs are awesome. You give them an application artifact, it'll give you a container, right? So if you give it a .jar, it'll create a file system that has a JDK and your application .jar, and it'll turn it into a container, and then you can deploy that. You can kubectl tag, you can do Docker tag and then Docker push, and then do kubectl create a deployment and reference that container, and you're off to the races, right? Or a PHP application or .NET application or Nginx or Ruby on Rails or Python or whatever. There's literally dozens and dozens of different build packs out there. But the core conceit of them is that, look, there's only so many different ways to package up a Java application. It's just not that special, right? A jar is a jar is a jar is a jar is a jar. There's no need for us to rebuild and reinvent all of this packaging every single time we go to production. So rather than do that, we encode the recipe for packaging a jar into one of these build packs. You can override which build pack gets used, but I think for example, for the Java build pack, you'll find that there are plenty of default assumptions that are provided there that are very reasonable, and you can override them if you'd like to using environment variables. So I almost never need to update the build pack proper. I'm usually just fine using the various knobs and levers that the build pack itself affords me. So Paketo is great. You can use that. There's actually a binary CLI called pack, P-A-C-K, and you can say, like you can see here, pack space build space and then the artifact, so dot or dot, my dot jar, something like that, and it'll create a container for you. You could do that, but Spring Boot already has support for build packs built in to the Maven plugin there, right? So I can actually just do on the command line here, cd Maven Spring Boot : build -image. And behind the scenes, this Maven plugin is going to talk to my Docker daemon, which I've got at my local machine here, and it's going to use build packs. So it's going to do the exact same thing. Now, of course, you can use build packs yourself. You can use build packs with other older Spring Boot versions before Spring Boot 2.3, and you can use build packs. The pack CLI. You can use it with non-Java applications, non-Spring Boot applications. But if you're using 2.3 or later and you're using Spring Boot, just use the build plugin that's already packaged in the Maven or Gradle plugins. And so this will take about a minute, maybe 40 seconds, to download the containers that are required to support the build pack, and then take our jar and create a sensible file system with the most up-to-date, most secure JDK and all that kind of stuff, and package it into a container, which you can see here. So Docker, blah, 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 Docker run, and we're off, okay? So that'll start up. Now, I like containers. I like build packs. I like that my application is already ready for production, but there is still the issue that it's Java, right? Java is a wonderfully robust, resilient, incredibly valuable piece of software. That said, there is no doubt that at runtime, it can take a little bit more memory than perhaps we wanted it to. And it can be a little slow to start up, especially in a containerized environment. We don't have full run of the CPU. So one thing that people are doing is to use native images. And when I talk about native images, I'm referring to GraalVM. GraalVM is it was originally a C2 just-in-time compiler, which is to say hotspot replacement that was written in Java. So rather than the spaghetti code C++ that is typical of hotspot right now, GraalVM was intended to be a Java on Java rewrite of the just-in-time compiler. And it's when you say just-in-time, another way to think of it is a compiler that when it sees a code path in your code that executes a lot, turns that Java interpreted bytecode into native machine architecture specific code. So you get the same thing as you might get for example, using Rust or Go or C or C++ or something like that. Now, the problem, of course, is that Java is not Go, it's not Rust, it's not C, and it's definitely not C++. Java is a very nice, dynamic, modern, very interactive language. It can do a lot of things because it has this concept of a runtime, and that runtime is also what allows us to be portable. I can take my Java jar and deploy it to Linux and Windows and Mac and whatever, and it works just fine. That's a great feature in 1995 when people are using applets, and the big concern is how we're going to run code consistently in every browser and every platform and every operating system with all sorts of different encodings and all that stuff. It's less, I think, of an issue today in 2021 when I'm running Linux in production. Just Linux. That's where I'm going to be. I'm running Linux, even if I'm running Windows. I'm probably running Linux containers, right? I'm still running inside of Linux somewhere. So what can we do? How can we get some of those benefits that some of those other languages enjoy, while also retaining the benefits of Java? Because Java, again, I wouldn't trade it for the world. It's an amazing ecosystem. The JVM is a miracle piece of technology. And the language and ecosystem are rich. And we wanted to support that with Spring Boot as well. So just recently, just last week, we released something called Spring Native. Now, Spring Native is not yet GA. It's not something I would recommend for production yet, but it is awesome. And so what I'm going to do is I'm going to go back here. Actually, this is the original build that we did earlier, the same initializer sequence there. I'm going to add Spring Native support. That's it. I'm going to hit Explore. I'm going to hit Copy. I'm going to go back to my build and paste that in. And what that's done is it's added the Spring AOT, or ahead of time compiler, Maven plugin, and it's customized which Paketo build pack we're using. This one is going to support native images, right? BP native images. And it's added this dependency, Spring Native. Okay, so when I say AOT, what I'm saying is ahead of time. The AOT plugin is a piece of infrastructure that we have where all the frameworks can contribute custom transformations that need to be applied to our code and custom information about the transformations that should happen, so that GraalVM can take our dynamic, free-spirited, fun-loving Java program and turn it into the very, very constrained thing that it needs to be able to run as a native image. Remember, what we need to do is to take our Java and get rid of all the things that make it Java, basically. Get rid of all, we have to treat it like it was C++, right? You can't do runtime reflection without any a priori knowledge in C++. You can fake it because you have a compile time, changes, but there's no runtime, so you can't do runtime reflection. The same applies here. We need to fake it, right? We need to make it so that all the dynamic things that we love about Java are actually, they seem to work, but it's only because we've tipped off the compiler that we're going to ask to do that. So things like generating proxies, that doesn't work. Things like accessing jar resources like class files and class jar files like a property file, that doesn't work. There's no jar, right? What does that mean, jar? There's no jar in the native world. Things like generating a new class into a custom class loader. Again, what does that mean? There's no such thing as a class loader, right? All that stuff has to be like shimmed in. You have to add a shim to sort of give the impression that that stuff exists so that the code still works, and yet it works reasonably in this native world. So we created the Spring Native project. It contributes a whole ecosystem of hints and tips for GraalVM. And so it knows about different applications, and it knows how to make these things work in the context of a native image. Let me go ahead and add that back here. Where's my plugins? Okay. And so there's a lot of things that I just dumped on you here. There's the Paketo build packs. There's also the fact that we can create a native image inside the build pack, which is what I want to do. You can also create a native image outside the build pack, but I'm not showing you that here. It's easier just to show you the build packs. So what I'm going to do is I'm going to go here, and I'll say Maven Spring Boot build -image. And recall that when I did this the last time, how long did it take? It was I did it here, didn't I? When I did this the last time, it took 41 seconds. I assure you, this is going to take considerably longer, because what it's going to do is it's going to create a closed world view of our code base, right? It's going to basically go through and say, oh, okay, Spring is trying to load this proxy. It's trying to do reflection on this proxy. Well, these are things that you need to tell GraalVM about. So it's doing analysis on all these things that we're trying to do in our Java code and creating hints. And those hints get fed into GraalVM. And then at runtime, when at some point Spring tries to create a proxy or reflect on a class, it's going to try and use the Java reflection APIs and the Java proxy APIs. And GraalVM is going to be like, oh, okay, I was told you're going to try and do this when we compile the code. Here's the make-believe reflection API that only knows about the few things that you've told it about, but it'll work, right? So suddenly it'll work as expected. This takes several minutes to do. The good news is you can actually influence this process, right? So actually, I can run the application right now, but it just occurred to me, one thing is going to break, something is going to break, and that thing that's going to break is customer. Customer is a custom object. It has its own fields and names and all this stuff. And when I do JSON marshalling, that won't work because Jackson is going to try and reflect on customer, but nobody has told GraalVM that customer needs to be reflectable, or I need to be able to reflect on it. So what I'm going to do is I'm going to go up here. I'm going to say type hint. Okay, type hint. Oops, I need to go back to my build as well and make sure I re-import everything. Okay, there's type hint. I'm going to say type equals customer.class. There are a number of different hints out there that you can use. There's also a resource hint. If you want to tell it about it like a property file that isn't like application.properties, we've already got those, but maybe you have some other property that you want to add or some other resource that you want to add. There's also proxy hint. So if you know that you're going to reflect on a custom type, maybe you want to create a proxy of type customer, you would pass that in here as well. Okay. And again, most of the hints are provided for you by Spring Native. You can also write your own Spring Native integration. I'm going to cancel this and we'll start again. You can write your own Spring Native processors, right? And you can provide your own hints. But for the 80% case, we're hoping you don't need to. We're hoping that we've thought of all the corner cases. Just know that there's a full suite of things you can do to extend that. It is not yet GA, right? The goal for us right now is to make this stuff available, get people using it, see what the use cases are. We've already got support for a whole bunch of different APIs out there. So if I go to Spring Native documentation here, and you can see support. Let's see. Here are all the different starters that are supported out of the box thus far. Right, Actuator, Elasticsearch, JDBC, JPA, Hibernate, right, Provider, MongoDB, Neo4j, Redis, JDBC, logging, Java Mail, Timeleaf, RSocket, validation, security, OAuth, client and server, reactive web, servlet, HTTP web, Tomcat, WebSocket support, Wavefront, by the way, that's also supported. We also have several Spring Cloud dependencies that work already, like the config client and the config server, the Spring Cloud function for serverless, the Netflix Eureka client, gRPC, Kafka, H2, MySQL, Postgres, etc. So lots of stuff is already supported out of the box. And you know what I just did, like literally this morning? I went to a project that I lead called Spring RetroSocket, which is also experimental. And I added, it's built, I have to fix the build, but I just got this working. It works now. I added a Spring RetroSocket native integration. So now you can use RetroSocket, which is a RSocket interface-based thing, right? I can give it an interface like this, RSocket client interface, and it'll automatically create an RSocket client for me. That now works. This works in native code. I don't have to, this is doing all sorts of weird stuff, but you don't have to worry about that. Just create the interface like you would normally, and it'll be turned into native code using the Spring RetroSocket native module. So the support is growing day by day, but we're still keen on having your feedback. And I personally would love to work with you to help understand your use cases. Eventually, this stuff will land in Spring Framework 6 and Spring Boot 3. So the next major releases of both Boot and Framework, and it'll just be built in instead of like a separate project. And so when that happens, I think I think that's the big horizon. That's next year probably, well, more than likely. But for now, this project is at 0.9.0, and it's not GA, but you can try it out. Eventually, I think we're going to have a GA version of this, keeping in mind that it's not the full-fledged integration that we're hoping for. That'll be in Spring Boot and Spring Framework itself. Again, you'll have the support right now in the Spring Boot 2.x series and in the Spring Framework 5.x series. It's just not part of the frameworks themselves. It's a separate thing. Let's see, it's still going. You can see that it takes a few minutes. It can take, when I first started doing native image work with Spring Native, when we had this project, when we announced it more than a year ago, the builds I would do would take on average like 10 minutes, right? It's not fast at all. This is definitely one of those things where you're going to want to get it right in your CI. You want to get it right and then put it in your CI environment. It's not going to be something that you're going to do on every single restart. So let's see here. Come on, finish up. It's taking its sweet time. And it's all, and by the way, it's doing all this with GraalVM. It's downloaded a container. That container in turn has GraalVM in it. It's then taken our code and it's now compiling it inside the Docker image. So it's going to create a Docker image inside of another image, right? It's the build step instead of the execution. Come on. Don't be alarmed by all these warnings. They are a bit terrifying, but you know, it's normal, it's fine. If you get an error, then you can be a little alarmed. Oh, good stuff. Well, while that's taking its time, let's go back here for a second. There you go. What I did today that I thought was a lot of fun was get the component processors working, right? A component processor is like I showed you the type hints and the native hints from earlier. Those are annotations and those work for, most use cases. Again, there's only so many different kinds of hints that GraalVM cares about. So you can use our annotation framework and that'll get turned into hints that get fed into GraalVM. But if those annotations don't do it for you, if you want to register things dynamically at run, at compile time, but using logic, business logic or whatever, some custom algorithm, whatever, you can do so inside of a component processor. And so behind the scenes, this gives you an access to something called a native context and your type system. And there I'm doing, this is kind of like reflection, but it's not, because it's by definition before you're running. It's not actual runtime code. And you can resolve what annotations are present, names of classes and all that kind of stuff. And you can programmatically register different kinds of types. So I'm registering, let's see here, context add reflective access hierarchy given this type. And we're saying allow people to do class methods and constructors for that type, reflection, that kind of stuff. So this kind of stuff is very, very powerful, and it's a little bit more involved, and you shouldn't need to do it, but it's just nice to know that you could. Okay, we're nearing the end. When you see this parade of like numbers here, oh, by the way, this is not for the faint of heart. If you don't have enough RAM assigned to your Docker daemon, it will not work, right? I can easily get up to 10 gigs of RAM in my Docker daemon here. So this is not, like I would normally show you this on my brand new Apple Silicon M1, but I've only got 16 gigs of RAM. Nobody has more than 16 gigs of RAM on an M1. So I'm using a creakingly old 2019 machine to show you this. So here's my container, Docker run -p. I'm going to publish the port to 8080 and run. Okay, there we go. Whoa, that was very slow. What just happened? Let's start that again. Okay, that's bizarre. Why is it taking so long? So it's starting up in a tenth of a second, 1.15 seconds. But I think it's because I'm screen sharing with you or something. Again, I can, like if I look at the Docker images that I've been creating for my RetroSocket example, those start up in 0.058. That is to say, 58 milliseconds. 58 1,000ths of a second to start up the application. So this is less than 0.2 of a second. It's less than 20% of a second to get it up and running. And then we can go to localhost, actuator, go to customers, etc. There's our data, right? And that's a container as well. So you can see I'm actually just running the Docker image. You can now deploy that into production and so on. So I hope you check it out. I'd love to hear more about that. Now, let me take a quick moment to answer any questions, and we have to run through the next 50 minutes because we have so much more to cover, but I wanted to show you all that stuff. So I'm going to stop sharing for just a second to see if there's any questions. Let's see. Publishers are things that produce data asynchronously. Please, okay, and networking. Yeah, the Git repository will be available later. the Git repository is there. Rather, the recording will be made available later. Is it possible to provide dynamic values for graceful shutdown timeout based on in-flight request count? I don't know. I don't think so. That'd be interesting to find out. That's a really interesting feature. I don't mean to be glib, but would you file an issue on Spring Boot? That would be kind of an interesting thing. Thanks. Can we override and provide our own hardened base image for Paketo build packs? Absolutely, you can. Yes, you can. That's exactly the point. You can provide your own container, your own Docker images, and so on. Talk about Project Loom. Yes. So Project Loom is a way to, OpenTelemetry. That's an easier one. OpenTelemetry it's not OpenTelemetry versus Wavefront. OpenTelemetry is an abstraction that corresponds to metrics, basically. You can use it so we support OpenTelemetry in distributed tracing, and I think there's support in the metric stuff, but we support that. And Wavefront you can talk to Wavefront that way as well, right? So it's just a Java API that you can use to talk to a backend system like Wavefront. And as to Project Loom, remember I told you about those 3 criteria for reactive APIs: resource efficiency, ease of composition, and robustness or reliability, right? So Project Loom addresses 1/2 of the 3 points, right? It makes the resource efficiency half easier, right? 1/2 of that 1 point. It's 1 out of 6, right? If you think about it. And what I mean by that is reactive programming gives me a way to reuse the threads that I've got, because threads are expensive. That's the underlying assumption there. Project Loom makes threads not expensive, but Project Loom has no opinion beyond making threads cheap. It's still just a thread. It's still a Java API that looks like a thread pool, and so on, right? So it's still just a very lightweight thread. That's all. You can just create more of them, but you're still dealing with threading. Threading is not your friend, right? Threading is a hard thing to get right. It doesn't address anything like ease of composition. It doesn't address anything like robustness. It doesn't help you with writing reliable, correct, multi-threaded Java code. So for all these things, you still need reactive APIs. And so Project Loom is going to be amazing. I am so excited about Project Loom. It'll make it so that I can create more threads more freely. But that still doesn't answer the question about should I use asynchronous IO or not, right? Because you definitely need to use asynchronous IO, especially even with Project Loom. Buffered, input streams and things like that have buffers that accumulate a lot of memory. They leak. So even though in theory you can create millions of threads, you definitely can't create millions of sockets, right? So yeah, I can't wait for Project Loom. It'll just make reactive programming even more amazing. And the nice thing about Loom is that if you've got an application that was having trouble scaling before, you might, with just a slight upgrade to Tomcat or something like that, be able to scale and meet that need. I'm not going to say it's cloud native. I'm not going to say you're going to have particular success, correctly responding to failure or composing data. But if you are dealing with old services and you don't have time to really refactor, but you still want better scale, Loom might give you that for free, and that's amazing. The Java team have done sorcery, just pure magic. Which gets us to the question of why Java and not Go or a more modern language? You say you had to disable a lot of the concepts of a runtime. Is that correct? Well, I had to disable a lot of concepts of the runtime to use GraalVM, but not really, right? You saw my code is exactly the same as it would be in regular Java. I just changed the build and I got GraalVM, which gave me the ability to pretend that I'm doing these things at runtime. Spring Native gives me the ability to pretend that I still have a runtime. And so then the question, if the question is not about the performance at runtime, if it's not about the ability to create native images like Go versus Java, then the question then has to be ecosystem and syntax. Go has a terrible syntax. I'll fight anybody who says otherwise. It's got a great ecosystem, but it's not going to be as big as the Java ecosystem. So, the question that might be, well, why not Rust, which has a much better syntax? And that's a fair point. You could try that. One thing I really like is Kotlin native. Kotlin gives me a very, very nice syntax, which I love. It's kind of like Swift, which is also very nice syntax. And Kotlin can compile to native code. But again, it's about ecosystem there, right? How big is the ecosystem for Rust? Not that big. And you can write Kotlin code on the JVM and turn that into GraalVM images. So now you get the best of both worlds. You get one of the most modern syntaxes out there, something that looks very similar to Swift or to to Rust, kind of, or TypeScript or whatever, but you also get to convert it. You also get to take advantage of the JVM ecosystem, and through GraalVM, you get the native performance. And going forward, by the way, friends, remember, Java 16 just got released. Java 17 is coming. The syntax there is getting a lot better, but going forward, some amazing things are happening. We already mentioned Project Loom. Project Loom is awesome, but there's another thing called Project Panama. Project Panama is a way to do foreign function interface, right? You can actually do native method calls. You can talk to, Win32 or, your POSIX APIs, low-level Unix and Linux and Darwin Unix APIs, right? You want to do malloc, from Java, you can now, right? If you want to do whatever, right? Anything you want, right? You can talk to these low-level APIs. And that makes life a lot easier, right? One of the big things that I love about Go and C and C++, or even other scripting languages, right? Like Python and Ruby and PHP and Perl and whatever. One of the nice things about those languages is that I can interoperate with anything. I can talk to any native feature very easily. Whereas with Java, as much as I love it, it hasn't been great at interoperating with local native code, right? So Project Panama will give us that. It gives us easy interoperability instead of having to resort to JNA or even worse, JNI, right? Okay, good. So let's go back to work here. Share screen. Thanks for the great questions. Okay, so now we have our reactive customer service. We've got a native image. I'm going to go ahead and restart it here. And now we're going to go build another microservice. We're going to go back to start.spring.io. And here, let's create a new service, and this service is going to be called the orders service, okay? And I'm going to use just one dependency called RSocket. I'm going to use Lombok, which is a compile time annotation processor. Is that true? I'm going to use no Lombok, and I'm going to use Kotlin. That'll make it. We can actually talk about Kotlin, one of my favorite little languages. So Kotlin is a JVM programming language. It compiles to bytecode, and you can use it to talk to any JVM library. So you can, of course, compile it to GraalVM as well. That's supported. Let's see here. Here we go. Okay, so this is a Kotlin application. Should be fairly straightforward. One thing that you should understand is that this right here is a separate standalone class. This is a standalone function. This function does not belong inside this class. I mean, it could be, but the point is, in this case, it doesn't. Just because there's no parentheses there, there's nothing you need, that is still a standalone class, and that's a standalone function. If I wanted them to be, a function inside of a class, like a member method, I can do that, right? But that's not what I'm doing here. So keep that in mind. Now, I have a class, I have a function. In Kotlin, you say fun, then you have the name of the function. You have parameters, and in Kotlin, the parameter variable name starts on the left and the type is on the right. And if you have a return type, it goes here, right? So int, for example, okay? So very, very convenient. Now, let's build an application that uses RSocket. RSocket is a binary protocol that was created by engineers who went from Netflix, who moved to Facebook. This binary protocol allows us to get around some of the limitations of HTTP2 and gRPC and so on. It was designed to give us a lot of different message exchange patterns, so not just request response, but also fire and forget, streaming, bidirectional streaming, and so on. It doesn't have a client service model. It's not like I have to connect to this thing to get a response. Once two sides are connected, either side can initiate the conversation. Either side can start sending data to the other side at any time. And that's the other thing. When you have two different RSocket services, they start up and they connect to each other, and then they stay connected. So the constant ACK and handshake and all that stuff that you do with the HTTP goes away. Now we have a stable socket connection that stays open for the life of the application, and that socket is multiplexed. So I can send lots and lots of requests over the same socket connection for the life of my application. There's built-in support for retrying connections and all that, but the point is, this is built for, this is an ideal programming, or ideal protocol rather, for homogeneous service-to-service kind of communication. It also is natively reactive. It reifies or makes concrete or makes real the concept of reactive programming, the concepts of back pressure, of flow control. It makes all those concepts explicit on the wire. This is different from HTTP. Imagine I have an HTTP client that connects to an HTTP service. The HTTP service uses asynchronous IO, and it uses reactive programming. But the client doesn't know that. It doesn't know about back pressure because the HTTP protocol itself has no accommodation for back pressure or flow control. That's not built into the spec. HTTP is HTTP. It doesn't matter how they're implemented on either side, the client or the service. Whether I'm doing the right thing with the reuse of my threads in my client Java code has nothing to do with how I communicate HTTP over the wire. But with RSocket, back pressure is something that I can signal, I can publish, I can emit, I can communicate at the protocol level. So it's a great fit for people who are trying to build reactive services at scale. It supports all sorts of different message exchange patterns and also any kind of payload. You can do JSON or XML or Google protocol buffs or message pack or Thrift or Avro or whatever, right? It's not like gRPC where you only have one encoding. So what I want to do is I want to create a service that's a RSocket service. Now I could use the RSocket Java or JVM library, and that is written on top of Project Reactor. So everything you've learned thus far, it will help you here. We like RSocket so much that we integrated it into Spring Framework itself. So in Spring Boot, I can actually just create an RSocket endpoint by saying Spring RSocket server port equals, and then picking a port. And there you go. It'll start up an RSocket service. Let's create a controller here. Okay, class order RSocket controller. And what I'm going to do here is I'm going to create an initialization, and I'm going to create a little in-memory database. Okay, concurrent hash map. And it's going to be an in-memory database of collection of orders. Okay, notice that I'm going to create a DTO here, a data class called order. Now I'm going to do this the Java way, kinda first, so we can see what we're not supposed to do. Private val ID int equals, whatever, right? That's okay, I guess. And I could have another field val name. But then, of course, the question is, why can't I nullify the value? Why can't I initialize it to null? Well, in Kotlin, the type system cares about nullability. So I have to add a question mark that says that this type can be null, and I need to have extra care around dereferencing values from that nullable value, from the nullable variable. The other problem, of course, is that I still need to create getters and setters and toString and all that kind of stuff. So this is not going to be great. I don't want to write this kind of code. Thankfully, I don't have to. Kotlin has a very nice syntax that allows me to create a constructor like so, right? Here we are. Good. So there's my constructor. And this constructor is pseudocode. It's a shortcut. It says create a new class with a constructor that has two fields, ID and name. And I don't have to default the values. I can just define it like this. But I can also say, look, I want these to be assigned to variables. I want the variables to be mutable, so I can make them var, right? If I want them to be, what this will result in is a class that has a getter and a setter, right? If I didn't have val or var, it would just be a constructor with two parameters, but no storage for the classes, for the fields in the class. So I'm going to make them mutable. That's one thing I can do. Or I can make them immutable by saying val. And most of the time, you're going to use val, right? If I want these to be private so that there are no properties, even though I'm creating val and var, I can make them private, or I can use some other access modifier. Okay, so what I want is actually an ID for the order ID and then the customer ID, right? This is a dotted line foreign key to the customer microservice. So notice that I have that now. Of course, I still want equals and hash code and toString. So I'm going to use this thing called a data class. This is a DTO, a struct, if you will. Okay, so I'm going to create a in-memory database of orders. Okay, and I'm going to store that data here in my little database of concurrent hash map. So let's do that. So for var, for customer ID, val customer ID in 0 to 8, right? I'm going to print out customer ID, right? That's my customer ID. And what I'm going to do is I'm going to create a list of orders, mutable list of order. Okay, and I'm going to now synthesize a random number of orders for this customer ID. So I'll say, well, first I'll say this.db customer ID equals list of orders. Okay, and notice that I can do dot put. This is an operator overload. Bracket is the same as doing put, right? It's exactly the same. I'm doing put, comma, customer ID, comma, list of orders, but I can also do bracket. It's a function, right? Bracket is a function. So let's see if I can, no, okay, well, whatever. So now I'm gonna create some random data. So I'll say for order ID in 0 to math.random times 1,000 as int, okay? Let's do 100, there you go. There you go, 2 int, okay? And what I'm gonna do is I'm gonna create a list of orders. I'm gonna increment to the list of orders. I'll add a new order object. So the object on the parameter on the left is the order ID, and the parameter on the right will be the customer ID. And I'm gonna then, that's it, that's the entire code. So that'll start up. Now I'm gonna build an RSocket controller endpoint, and I can do that using the familiar message mapping component model that's part of Spring, since Spring Framework 4.0, which is, 6-7 years now. Orders customer ID, fun get orders for destination variable customer ID, right? Int. And I want to return the data. I'll say, okay, return. I can do it like this. I can say return the data from the orders. I'll say orders this.db customer ID. And I want to turn that into a stream. So val stream equals flux.from iterable orders. And I can return the stream. Okay, that works fine. Now, of course, I need to define that here. I can say publisher of order. Good. So that's my updated code from iterable. Oh, what is the issue here, friend? Collection. Oh, iterator. Iterator, come on. Is that not gonna work? Oh, is this, see the problem here? I can, sometimes the type system gets upset. So I'm creating a variable assuming that it's gonna give me a list of orders. And the collection, the map has a contract that says it can return null. So I need to tell the compiler, hey, look, I know you could give me null, but I'm not worried about it. So just go ahead and give it to me anyway, and don't worry about the nullability. And so it's at this point that I get upset and frustrated and I start cursing. And it turns out that in Kotlin, that's the right thing to do. See, I'm gonna use this to collection. Okay, there we go. So there we go. That actually, that exclamation mark tells it to not worry. It says, I know what I'm doing. Just go ahead and give me what I want. I'm going to inline that. That's fine. I can also then put this whole expression in here because why not? And actually, when I've got a whole function with a body and all that stuff just to return a single expression. And if you have that, then you can just do this. Right? You can just do an expression. So that's my entire function, right? That's my entire controller handler thingy. Let's go ahead and run this and see what we get. Cool. Did I print out the customer ID? I did, look at that. So there we go. So there's our RSocket service. Let's go ahead and interact with the RSocket service to make sure everything's working. I'm gonna use the curl of the RSocket world. I'll say RSC, TCP, localhost 8181. The route is the endpoint, so it'll be orders for customer ID 2, and the interaction model is a stream. I'm sending 0 or 1 record in, and I'm getting 0 to n records back, where n again is potentially unbounded. So I hit go, and I get the response, right? 3, etc. Okay, so that's RSocket. We have an RSocket service. We have a customer service. Now I want to build something to consume both streams of data, okay? And so I'm going to create an edge service. An edge service is a logical, it's a logical thing that sits at the edge of the architecture. And it's a great place to do cross-cutting kinds of concerns, to do anything having to do with adapting requests from the outside to the downstream services. And here I'm going to use Spring Cloud Gateway, which is an API gateway. I'm going to use RSocket. I'm going to use Lombok. I'm going to use the reactive web support. And I think I'm happy with that. Do I need anything else? Let me make sure I've deleted all the zip files here. I think I accidentally downloaded Gateway. I did. Goodbye to that. So Gateway, RSocket, Lombok, reactive web. I think I'm happy. Let's go ahead and hit generate. And we're going to open this up in the IDE like so. All right. So gateway, it's a public static void main Spring Boot application, Java. And I can do two things here. One is a gateway. API gateways are a great way to ensure a consistent quality of service for downstream microservices. It's a great way to re-centralize some of those concerns that you would have to otherwise redundantly address in each new microservice. Things like routing and rate limiting and security and federated authentication and compression and retries and status codes and all that kind of stuff that would be nice to have in a single place. All those things that you wouldn't have to worry about if you were doing a monolith. Those things that become redundant things that you have to do for every single new service. We want to re-centralize, we want to, consolidate all that if we can without returning to the dreaded monolith, because we lose the autonomy that we were talking about earlier. So gateway is a great way for those things that you can do in a generic cross-cutting kind of fashion without intermixing business logic to re-centralize some of those concerns. And we have an abstraction. We have a project called Spring Cloud Gateway. And Spring Cloud Gateway has a great API called a route locator. And the route locator is what you use to define routes. And when I say that, I mean, it's literally just that. It's an interface that returns a stream of routes. And these routes are just DTOs. They're objects with IDs, URIs, predicates, etc. But nothing special here. You could define these routes any way you wanted. You could load them from a database. You could read them from a config file. In fact, Spring Cloud Gateway has a YAML or property-based configuration mechanism that you can use as an alternative to the Java API. And that configuration can live outside of the application itself. You can put it in Spring Cloud Config Server. You can dynamically reload that config server at runtime and then reread the configuration from the config server as needed, right? So there's a lot of opportunities there. You can treat it kind of like a turnkey appliance. Okay, so now for each Spring Cloud Gateway application, you have 0 to n routes. Each route has a predicate, a set of filters that act on the incoming request, and then a destination. So predicate matches incoming requests, filters act on the request, and the destination is where you're going to send that request once it's been processed. So I'm going to create a predicate that says that all requests that come to my Spring Cloud Gateway node, which is going to run on port 9999 or 8888, whatever, all those requests need to go to this host and port, okay? And it must have this vhost header, and it must have this path. And if it matches, then I'll send it to, let's say, localhost 8080/customers. Here's the problem, friends. First of all, if the request comes into this host and port, it's going to hit /proxy. /proxy is the path. Well, that's the path of the incoming request. Spring Cloud Gateway is a proxy. It's going to take the request and send it directly on to the downstream destination, which is the URI. Well, it's going to take the path and append it to whatever we give it here. So it'll say customers /proxy, which of course doesn't exist. So what I want to do is I want to change the incoming request and drop the existing path and replace it with customers, right? So that's a filter, and this is where you can act on the incoming request as it passes through the gateway code. And here you can do all sorts of interesting things. This is the real power, is all these different filters. You can add request headers, do a rewrite on the path or the URI using a regular expression, just like mod rewrite or nginx or whatever. You can do a custom filter. You can just write your own gateway filter code. You can do retries. You can do circuit breakers, so that if something goes wrong in processing the request, it'll forward to another gateway route, and then that route can do whatever you want with it. You can send it to some sort of fallback screen or something like that. I can do modified request response. I can prefix the path. I can preserve the host header. I can do a redirect. I can remove headers. I can preserve the session. I can set the request to response. I can set the status code. I can do all sorts of interesting things. I can do a token relay. So if you have a downstream OAuth, the resource endpoints, resource services, and they only accept a token, they don't incept the token, right? If you want to do the inception, that would happen at the gateway at this token relay endpoint. if the request comes in and there's no token, it'll redirect you to a place where you can authenticate and do the OAuth dance, and redirect it back to the gateway with token in hand, and that'll then get forwarded down to the downstream resource server, right? So lots of different things that you could do here. And that's really the power of Spring Cloud Gateways. You've got all this support out of the box. So if I wanted to do cores, cross origin request scripting, for example, I could say, great, let's do that, right? That kind of thing. Very, very trivial. So that's my simple gateway. Let's go ahead and run this and see what we get. Okay. Localhost 8888 / proxy. That's not going to work. I need to go to the command line because I have no host header. So if we try that, -v, it fails, right? 404 not found. Good. So now we go to here, -h, host is hello.spring.io. And there you go. So it says, okay, HTTP 200, here's your JSON data. And we've added this custom header that didn't exist the first time. You can see there's no access control at origin header up here. So this gateway has taken the data. It doesn't know about what data I'm sending to and from. I mean, I could write a filter and then pluck that data out of the request and transform it in some way, but that's not the right place to do that kind of stuff. I typically find that if I have business logic that relies on surgically, cutting and slicing and dicing my payload in some way, it's probably the wrong place. And that's just like a generic thing that you can do ignorant of any particular request, right? So headers, for example, anybody can add an authentication header. That's a great thing to do at a filter level. A status code, that kind of thing, okay? Okay, so we have a simple Spring Cloud Gateway. Another great thing you can do at the edge service is an API adapter. API adapters are aware of the payload. They do have some awareness of the semantics of the payload, and you can create API adapters that transform the payload in some way. So let's create a API adapter using reactive APIs. And this is one of the wheelhouses for reactive APIs, is the smooth ease of composition, the service orchestration and composition use case, the scattered gather kinds of service orchestration and composition. So in order to support that, I'm going to create a client to talk to our downstream RSocket service. So I'm going to use an RSocket requester. Okay. And we're going to have private final web client, HTTP. And I'm going to create a component. And I'm going to inject that into the constructor. But of course, I need to factory these beans. I need to vend them or produce them or whatever. So I'm going to create an RSocket requester by using the builder. I'll say return b.tcp. I'm going to connect to localhost 8181. And notice, again, I'm doing this at startup time as opposed to at runtime when I'm actually making the request, because there's no need. I just need to specify it once. Here's my HTTP client, same basic construction. Okay. So RSocket and HTTP, great. These will be injected here. And now I want to create some endpoints to get the data. So I'll say, okay, give me a stream of customer. Okay, get customers, return flux.empty for now. And of course, I need the DTO for the customer. So I'm going to do the wrong thing. I'm just going to guess private integer ID, private string name, at data at all-rx constructor at no-rx constructor. Good. Okay, there's my customer object. And then, of course, we have the order object, which I get from the RSocket service. So private integer order ID, customer ID. Is it order ID? Is it just ID? Let's go check. Here's my order type. It's ID and customer ID. So order ID and customer ID. Good. So there's that data. Okay. So that's my basic construction there. So it's a stream of customers and a stream of orders for integer customer ID. Now let's implement these, okay? So the first one, straightforward. We use this non-blocking HTTP client .uri HTTP localhost 8080 /customers retrieve body to flux, customer.class. Okay, there's that. And then we want the orders. And we want to say, okay, give me the orders from the RSocket service. And again, don't care that one's RSocket, one is HTTP. They're the same API. When I get the results back, they're just streams of data, right? So RSocket, the route is orders by customer ID. And the data that we're going to expect back is of type customer. And there we go. So this assumes, both of these interactions assume that everything is going to work just fine all the time, which of course is a little bit naive. So I can use these operators that I get to, for example, retry 10 times, retry when something fails, and back off, and then back off, an exponentially longer period of time, for example. I can do an on-error resume to degrade gracefully so that if there's an exception, I can decide how to handle the error rather than communicating an error or stack trace back to the user. I can also do a timeout. Timeouts are great if you want to guarantee that you meet an SLA, and you can cut bait and run or abandon your attempt if you exceed a certain time for your SLA, right? But remember that this is not the only way to ensure that you meet SLAs. Timeouts are a great thing to have, but I would consider them the last defense, right? They're not the best way. Because you only get, imagine you have a typical SLA, you have 20 seconds, which again, I grant you an exceedingly long time, right? It goes on forever, but let's say you have 20 seconds and you need to call some other downstream service. So you call that downstream service, that means you've got 10 seconds. That means that if that service doesn't return within 10 seconds, you have to do a timeout, and then then you've got 10 more seconds to try again on some other service. Well, that means you only get 2 bites at the apple. You only get 2 shots. Much better is instead to use something called hedging. Like in English they say, don't put all your eggs in one basket, or hedge your bets, right? So I want to hedge my bets by launching the same identical request to 3 distinct instances of the service on 3 different hosts and ports. So it's the same service, same API, same everything, it's just on different hosts and ports. That way, if one of them is out to lunch or garbage collecting or down or whatever, one of them is bound to work, right? It's statistically, the more shots I have, the better. I'm launching all 3 at the same time. And by the way, I use 3 just anecdotally. It can be any number greater than 1, right? Like you can do 2 or 5 or 10 or whatever, or a percentage. And of course, if you want to programmatically ask the cluster, how many discrete instances of a given service do I have? You can't use DNS for that, right? DNS isn't going to be a great fit there, but you can use a service registry. So Spring Cloud has the discovery client abstraction that allows you to programmatically load balance across the different instances. But that would look like this. Here's a very quick example, right? If you wanted to assume you have 3 different instances, 3 different hosts and ports, and I'll leave this bit right here to your imagination, but just, TLDR, it would look like that. You'd copy and paste that, place it here, change the host and port, and there you go. You've got 3 different pipelines, but you haven't launched any of them. And so now what you want to do with hedging is you launch all 3, and the first one to produce a response, you keep that one, and you apply back pressure to the other 2. That way, if they start spinning up and start trying to respond to you, you're not going to waste too much time, right? You might waste some time, but of course this is redundant. In the best case, you'll end up making the same request 3 different times to 3 different services. So you're going to waste CPU time on those other 2. But hopefully, first of all, they're using reactive APIs, so it's not going to be that big of an impact on your ability and availability for those services. And second of all, you can apply back pressure so that you can stop them before they get too far down the path. And third of all, it's better than not having a response. I'd much rather have 3 responses than none, right? And of course, with that in mind, you should definitely not do this on the charge the customer credit card endpoint, right? This should be done on idempotent endpoints that you can invoke multiple times successively without any undue observable side effects. And to implement hedging, you can just use these nice operators, right? Very, very convenient. Imagine trying to write that code with threads, right? With runnables and cyclic barriers and countdown latches and executors and all that stuff. It would be very tedious indeed. And it's a nightmare. And remember, there's only one person that truly understands how to write safe, effective, multi-threaded Java code. And it's not you. It's definitely not me. I don't know who it is. You don't either. That's the point. Don't do it, right? Let the framework help you out. And this is a great example of where I want a really big thing, but I don't want to waste a lot of really big time. And so, the operators in Reactor help me get there faster. Okay, so I have my customer data. I have the orders, and I can add these. And these, by the way, these operators, retry, on error, timeout, these are parts of Flux and Mono. They're not part of RSocket or HTTP. So I could have done the exact same thing up here, right? Nothing changes. It's exactly the same code. Get rid of that. There you go. Okay, so now I've got my customers and I've got my orders. Let's now create a new view of the data. I'm going to do scatter, gather, service orchestration, and composition. I'm going to get, for all of the customers, I'm going to get all of the orders. So private customer, and private list of orders, or orders. There you go. So data, add all orgs, no orgs. And I want to create a new endpoint here. Give me a customer orders, get, come on, Josh, get customer orders, return this dot get customers. And then for each customer, I want to keep two things in memory at the same time. One is the current customer, and then the other is the orders for those customers. So I'm going to use what's called a tuple. A tuple is an object that has slots for different objects and for the type of those different objects. It's like an array, but each element has its own type, and it's not necessarily unbounded. It's usually great for small, 5 or 6, a handful of objects, right? And you can create that easily using the zip operator, right? And so I'm going to use the zip operator here. I'm going to say on the left, the item on the left is, the first item is the customer wrapped in a mono, and the item on the right is the orders as a list. So I'm going to say collect list, and so what that's going to give me here is if I flat map it, it's going to give me a tuple, and I can use the tuple. I can say give me tuple dot, no, that's not right, mono. Did I do something wrong here? Okay. Oh, flat map here. Sorry, friends, brain's out to lunch today. So T1 is a customer, and T2 is the list of orders. See that? So you can see what I need to do. I need to take those types and create a new customer orders type. T1 on the left, T2 on the right. Whoa. Okay. And that's it. That's the entire pipeline. That's the entire way to express this otherwise very complicated thing. I'm doing scatter, gather, service orchestration, and composition. I'm calling two different sets of services concurrently. And as the results arrive, when they arrive asynchronously at any point in the future, they get coalesced into this one view of the data. So for all the customers on the left and all the orders on the right, create a new stream showing me all the customers and orders together, right? And there's no weirdness around correlation and synchronization and waiting for things to happen and blocking and any of that nonsense. It's just really, really elegant, clean code. So now let's actually demonstrate that in action. I'll create a customer orders REST controller here, at REST controller, class customer orders REST controller, CRM client, and get mapping COs, publisher of customer orders, get return this.crm client dot get customer orders. Okay, I'm going to inject that into the constructor, and we'll go ahead and restart this. Let's see what we get. And I'm about to wrap up here. Give me half a second. Localhost 8888 COs. And there we are, my friends. There's our data. Customers, you can see that each element is a customer and order combo, right? So there you go. So there's customers and orders, right? I can see all the orders for each customer. It's really fast. It's working as I expected to. This is actually the worst case scenario, right? I'm actually doing an N+1 query here. I'm saying for each customer, go out and get the orders. That's not what you want. Ideally, what you want is an endpoint that'll give you all of the orders for a range of customer IDs, and then in your client memory, in your Java code, on the client side, then you can filter, sift out into different streams each of the results. But again, this is still blazingly fast because it's being done concurrently. I'm not in a serialized fashion. I'm not waiting for things to land and then doing the next thing. Really, really powerful stuff here. And this is why this is a great way to build services that scale correctly, that do the right thing, that never waste CPU time and so on. Obviously, I've kind of hand waved away the question of writes. For writes, you're going to want to take advantage of not two-phase commit, not distributed transactions, but something like the tell, don't ask pattern. And in this pattern, you publish events to other nodes in the cluster, and they update their own internal view of the state of the system to reflect those events. So the order service might be storing its data in Redis, and the customer service might store its data in Neo4j, and then you might have a third service that's storing its data in some SQL data store, right? Each one of them is going to have their own representation, their own denormalized, perhaps, view of the data. If you're using Cassandra, it's very natural to have a denormalized view of the data. And so you want each of them to store the data however makes sense for them, and to make reading the data as fast and as efficient as possible. But you're not going to tell them, you're not going to wait for them. You're going to say, okay, here's a message. It'll be delivered on a broker. They can acknowledge the message and do whatever they want on their own time, and the view will get updated that way, right? The world view will get updated that way. And you can use Spring Cloud Stream. And when you use Spring Cloud Stream, you would create a Spring Cloud function. And that function is based on Java util function, right? And the parameter types can be, you guessed it, a stream. And so Spring Cloud function allows you to take a regular function and pair it with either a broker, a message queue, like Google Cloud PubSub or Redis or Kafka or RabbitMQ or whatever, and it allows you to take it and talk to a message queue using a function as a handler, as a callback, or you can bind that function to a function as a service provider like AWS Lambda or whatever. So either way, it's a function that gets invoked whenever there's a new message coming from either Lambda or from Kafka or whatever, right? Same Java code, you just change the build. But we don't have enough time for that. I do want to thank you so much for your time today. I hope you got something out of it. I hope you learned something. I'm going to answer some questions now. I hope you liked it, though. I'd love to know if you got anything out of this. Let me know in the chat. I want to encourage you to reach out to me, send me email, whatever, Twitter. If you have any questions, comments, feedback on anything that we talked about today. And remember, you don't have to take my word for it. I mean, obviously, I love this stuff. I'm wearing the spring t-shirt and the spring underwear, but I'm not the only person out there using this stuff, right? There's a lot of really interesting organizations, small mom and pop businesses that are using this stuff to great effect. So, for example, Alibaba, Huawei, Netflix, eBay, all these different organizations, the largest on the planet, are using Spring and RSocket and Reactive and so on. Thank you for your time. Hope you're all healthy, happy, and safe. And
Josh, I opened up the audio for everyone. Feel free to, if you can stay for another 10 minutes, Josh.
No problem. Hopefully we can all do this again.
I know there was a couple of questions there. One was around gateway is great, but why not Nginx or Apache web server versus, or a router, or ingress router, for example, versus the gateway? And what are the advantages of using the Spring Cloud Gateway versus those other pieces of software?
Well, so good question. There's two different kinds of gateways, right? There's, when you talk to network people, they're going to talk about gateways, like network gateways, like switches, things like that. That's a different kind of gateway. And then there's application gateways like Spring Cloud Gateway, which is more like an API gateway, more like Apigee or Kong or something like that, right? So Nginx doesn't address the application gateway concerns. For the network gateway kind of stuff, like proxying and so on, Spring Cloud Gateway is very fast. So the real question is, why Nginx or Apache? Especially if you have more control over how you're doing things. If you can unit test it, you can compile it, you can run it, and so on. The other thing is, you can use Spring Cloud Gateway as an ingress controller for your Kubernetes cluster. You can use something called Spring Cloud Gateway for Kubernetes. That's a product. It's not open source. You pay for it. But the nice thing about that is that you can describe the routes for your microservice in the deployment pipeline for each of your microservices, and they get contributed to the global ingress, the global gateway CRD in your cluster, and then that acts as the ingress for services for requests going into the cluster. So the definition of the routes live along with the microservice, but there's only one of them in the cluster, right? And so it's a very, very powerful mix. It's kind of like an Nginx controller there in that particular use case there. But Nginx is fine if you're using it. If you're happy, that's fine. But again, there are a lot more use cases that are well served.
I also heard I've also heard almost like a micro gateway as a reference to that model, like having multiple micro gateways using Spring Cloud Gateway. Is that more of a usage there, Josh?
You can use that as well. You can have multiple Spring Cloud gateways because the gateway can hang off of the side of your business logic. It's not a separate piece of infrastructure unless you want it to be, right? I can write business logic, although I wouldn't necessarily at that level, at that logical tier. Makes no sense at business logic, but it is nice that I can program it. Istio versus Spring Cloud Gateway. Yeah. Great question. Yeah, I would use Spring Cloud Gateway, right? Like you can do, especially the Spring Cloud Gateway for Kubernetes. That does authentication, mutual TLS, that kind of stuff. I think it does mutual TLS. I'm pretty sure it does. All those use cases that you would think about for Istio are well served by Spring Cloud Gateway for Kubernetes. Plus, it's Spring Cloud Gateway, so you have a lot more flexibility. It's not just an Istio, right? It's an API gateway, a full-on API gateway, not just a service mesh. It's not just a proxy like Nginx either.
Also, there's a question around price. Everything that you talked about today, Ensure, has no price attached to it, right?
Except for Spring Cloud Gateway for Kubernetes, which I didn't show. I only mentioned it briefly. Everything else, yeah, for the last hour and 49 minutes, on that last 50th minute of the second hour, there's a price.
Awesome. So thanks. Anyone else? Any questions? Please unmute yourself, and you can definitely ask a question or any other interactions. Good to see you, Deshaun. No.
Sean, what's up, buddy?
I'm here. That was great. That was classic Josh. I could almost keep up for the first 5 minutes.
Awesome. Any other questions before we close for Josh or us? So I think we will announce our next session in a couple of days or maybe a week. We are finalizing some of the topics. Some of the topics that we are talking about potentially bringing in the upcoming sessions are Knative and how we can learn about Knative and then potentially start using Knative in multiple different use cases there. Another topic that's in the works is talking about SRE. What is the role of SREs in the world of cloud native and the world of DevOps that we live in today. And also please let us know if you have any other topics that you would like to be like to listen about and talk about. Happy to find the right people for those discussions and bring them out here. So once again, thank you very much for joining us today, and I hope that we'll have a lot more of these sessions in the coming months.
Look forward to it.
Out there.
They asked about the recording. When will that be available?
As soon as Zoom gives me the recording, I will paste that out on the event site on Meetup.
It's typically less than 24 hours. So that's
Josh, you're okay with me putting that on YouTube and sending a link there, right?
Of course, please do.
Okay, cool. So thank you very much. And then as Josh said, you can always reach out to him. He's one of the most accessible person. Twitter is the best way to reach him, by the way. So tweet at him and he'll respond to you. So thanks a lot, everyone, and have a good night and stay safe out there.
Yeah.
Thank you. Thank you again. Thanks, Josh.
Thank you for having me.
Thank you.
Bye-bye.